This is question 40 from the GATE 2019 EC paper, where we are given this NMOS pass transistor based circuit and asked to find out what the values of Vout1 and Vout2 respectively are. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic.
So in the circuit shown, the threshold voltage of the NMOS is 0.6 volt, right? So every NMOS shown here has a threshold voltage of 0.6 volt. We have been asked to ignore the effect of channel length modulation and body bias. Now mainly what this means is that the sources of the NMOS, right? The sources of the NMOS can increase in voltage or decrease in voltage, and it doesn't affect the threshold voltage of the transistor, right? Because the VSB is what affects the VTH by effect of body bias, right? But we've been asked to ignore that, so we are basically saying that VSB has no effect on VTH, right? Since B is assumed to be grounded, it's only Vs that we are concerned with, so therefore we can even ignore that. Now let's analyze the first circuit, circuit 1. So in this circuit, this transistor has a gate voltage of 3 volt and a drain voltage of 3 volt as well, right? Remember that if current is flowing this way, this is the drain and this is the source. Now what is to be noted is that in an NMOS transistor, the current is greater than or equal to 0 if and only if the VGS is greater than equal to VTH and the VDS is greater than equal to 0, right? For anything else, you will have that the current is exactly 0. So in fact I can use strictly greater than here for strictly greater than VDS, and for otherwise the current will be exactly equal to 0. So if you imagine that there is a capacitor here to ground and it's charging up, it will only charge up for as long as either the VDS becomes 0 or the VGS, remember this is the source, so that's the VGS, or the VGS is greater than the threshold. So there is a problem here because this can't rise up all the way to 3 volt, because as soon as it rises up to 3 minus 0.6 volt, the VGS will become 0.6 volt and then the current will stop. So the maximum this node can go to is 2.4 volt. Now since this node is the gate of this transistor, the maximum this node can go to will be 2.4 minus 0.6, which is 1.8 volt. That's the answer for the first circuit. Now in the second circuit, we have the same condition over here as in this situation, drain and gate are both at 3 volt. So this will at most go up only till 2.4 volt. But of course now this can pass without any hindrance over here to 2.4 volt, because this node is 2.4 volt and so it's 0.6 volt and it's still VTH, and so therefore that's fine. But the current will keep flowing until VDS is 0. So in this case, the drain and source being at the same voltage is also not an issue. And similarly, this 2.4 will again, it's exactly the same case, will get passed on over here. So Vout2 will become 2.4, Vout1 will become 1.8. So the values of Vout1 and Vout2 are 1.8 and 2.4 respectively. Thus the answer is C.